Hey, there it goes. It does what it does. It has a mind of its own, and sometimes it just doesn't want to cooperate. The stream, it will like tell me when I try to start streaming that it'll say like forbidden, or it will say the thumbnail is bad, and I've literally been using the thumbnail. I've been using the same thumbnail for like, I don't know, a year and a half now, so it's just really strange. I have to disconnect from the account, and then I have to reconnect to my YouTube account, and like then eventually after I do that like 2 or 3 times, just kind of like this random process of like trying again, all of a sudden it will finally start to work. Why? I don't know. I don't really understand it, but that's the way it is. I can't really fix it. Like I do what I can, and I can't control how it operates, can I? It's some weird thing that happens, and I just don't understand exactly why it does that. Alright, so let's get started. Hope you're having a good day. Andrew Surio. Alright, yeah, everything's working, I think. The volume should be good. Check the volume. Okay, so today we're going to be continuing finalizing save logic files, save load logic, basically part 6. So we're just going to go ahead and copy this. So it's going to be part 6. And, well, we didn't actually start at 11. That was the goal. I set that. I actually started at 11:15, but I had to debug it for almost 10 minutes, so I lost 10 minutes there. It is what it is. Life goes on, right? Okay, so let's go ahead. Let's do the damn thing. What did we do yesterday? We continued and finished going through save logic, master save object list. We were determining the final form of namespaces for object names, and also including final pass pseudocode comments for proper save load logic for each data point. So we finished that yesterday. Praise the Lord, it's done. Now we're on to the next step, which was determining proper order of operations for updated save system regarding the perspective of client pi for when/how save state function will be called. And we stopped at line 272 in save logic pi. So let's go ahead and hop over there. Alright, so this is where we stopped. We said we need to determine at what point in the context of the above save functions will this function be called. Go through each function and think about the overall structure of these function calls from the perspective of client pi to figure this out. Ensure we are not being confused about order of operations, boots on the ground logic, etc. Below function, yeah, but that's different. Okay, so before we can, well, we actually could just finish save state first, but I think before we like finish save state, we should make sure that this save state function is gonna be like valid. I'm like 99% certain we would surely use it, but I do want to look at like how are we going to call them in what order, because I just feel like it needs to be clarified a little bit before we go too deep, just in case something needs to be changed or whatever. I do want to review that. So let's zoom back out and just skim over this entire process. So this is the save logic file. It has the database class. We have the master save object list. That's the list we just finally finished going through. And then we have some other random shit. Okay, this is what we want to look at. We have the different functions here, methods rather, of the database class. We have the save database setup function. And you know, I have heard this a lot. I would rather not hear this one. I have listened to this many, many, many times. I would rather just listen to this dude. We're just gonna listen to this dude today. Hopefully he's not whatchamacallit, copyrighted. I guess we'll find out, right, if we get a strike. But yeah, I kind of liked his stuff. I discovered him the other day. Okay, so we have save database setup function. This just does the creation of the database file, creates the cursor, sets the journal mode, creates the table. So this creates the first database and the table. Very straightforward. And so we'll just put a description here, so because I feel like I need to do that. Below function 2825 creates the database file, or the initial database file, which is called savedata.db, and the associated cursor, as well as the table save data, and sets up the pragma settings. And pragma just sounds cool, doesn't it? It makes you feel cool to say that. Alright, so what's the next one? So that one is going to get called probably inside of setup or something. We'll figure that out later. Okay, now we have the visual data save function. And the purpose is to function which is run to save data associated with visuals. And all it does actually is it serializes the data and insert. So this should be initially we were going to have this handle visual data, but really what it does is it's basically just a quick like calculation, like an add function almost, where it just does a basic task. It serializes the data that you pass to it, and then it inserts into the database the object name and the data that you had passed into it. So basically every time we would insert to the database, we would call this function. So instead of us writing, serializing it, and then having to rewrite this syntax properly every time, we could just call this function, and all we have to do is pass in the object name string and then like the data that's not serialized yet. So we should really change this to say function which is run to save data. Yeah, that's not true. A function which is run to save data. So this is just really to, which is run, and we don't even need to put that. We would just put to reduce lines, serializes the data arg and inserts into okay, and it's using self cursor. So cursor is created in that last function. So this would insert it into the save data. So it inserts into save data.db instead of having to type this out over and over. this function streamlines the process. And then we have params, which is object name, type stringer int. If card object, then integer. Otherwise string. Okay, that makes sense, I guess, for certain certain like objects are just representations of individual cards, like draw card. If we save that, even, I don't know, we might not even like save that, but we can always modify that comment. It's not a huge deal. We use int for card data to streamline retrieval process when loading this data in. Well, and that's pretty much also the only way you would be able to save it. Type depend string int etc. The data associated, it could be a list. Yeah, it could be a list. The data associated with each object name namespace to be saved for data restoration after DC. Okay, that's fine. So this function, I have refreshed on it and I understand it. All right. Now this function here, custom append list save function. Are we still going to use this? I don't think that we should at first glance, since we are. Is this louder? It shouldn't be too loud compared to my voice. No, it's like half, so that's about right. Are we still going to use it? I don't think we should at first glance, since we are now saving data at one checkpoint only, 1x at the beginning of each main while loop iteration. It seems like this would cause issues, and we should probably disable all calls to this function or remove them completely. So let's read the comment for it. Purpose: using custom append list by and various methods to handle saving data to database. Used in append, pop, and clear. Params and method string type purpose. Yeah, we put a lot of work into this. Kind of sucks. I remember working really hard on this. Spent, you know, I don't know. I spent a good bit of time fucking working on this function. It always sucks. It's not a huge function. Probably took me a couple hours to get it like perfect, you know, and to review all the logic and make sure it was like watertight. But it sucks that I don't think we're gonna use this because we're just, I don't know. Maybe we will. Maybe we'll leave it around if we want a more like up-to-date save system that's even more like refreshed than persistent than once per while loop, which once per while loop is pretty like often. We're talking about like every quarter of a second probably or something like that. I don't know. Well, actually that depends, right? It depends on how much data is being applied per while loop. So we may yet end up using this, right? We may yet end up using this, but as it stands, I just don't think we should use this, because let's go ahead and see what it does. So it basically is called in it's called alongside the append, pop, and clear methods in the custom append lists, which are the visually represented card card groups rather in the game. So like the player's hand, the player's play cards, the pre-sort play cards, the melds, the red 3 meld, all those are visually represented custom append lists. And what this does is it basically it just saves the state of the card group to the database every time one of these methods is called. So instead of, like, let's say you hit a while loop iteration, the while loop iteration consists of receive data, apply data, draw the screen, and then send data. Or it's not necessarily in that order, but it consists of those 4 steps. So let's say you receive a large packet that has like from the server side, you're the client side, you receive, I don't know, you might actually receive a pretty large packet where it's 8 different cards being appended to the hand or whatever. So that one while loop iteration would end up calling this append function to 8 times. So with the current system, with just one save per while loop iteration, we only have like basically if you disconnected before the 8 cards finished and it got to the next while loop iteration and it made the save, and now it saved the 8 cards in your hand. If it didn't get to that point, then without this function being enacted in this method, this process being executed, you would just lose that progress of those 8 cards. So, which is not good. Obviously, it's lost data. But the issue is, like, we're trying to keep it as basic as possible, at least to start. And the once per while loop is pretty safe. It's like, it's really easy to get it set up and get running. So this is another like next layer of the onion of data persistence complexity that would, instead of reverting you back to having the 8 card, like from 8 cards back to 0 cards, and you having to set up those 8 cards again, it would actually like save each card one by one. So instead of 0 and then 8, you would have a save state at 0, at 1, at 2, at 3, at 4, at 5, 6, 7. So if you got disconnected at the 7th card, when you reconnected, it would reconnect at the 7th card. It wouldn't send you back to the 0th card and redo the whole process again. But like I said, we're starting off simple. Because it's a big system, there's a lot of working parts to it. So to test it, at the very least, we're just going to keep it simple at first. If we want to add more complexity to it and we work out all the kinks in the once per while loop iteration system, then we can add this next layer of complexity. And look, the function's already created. So all we have to do is just basically re-enable the lines. So I think what we'll do is we're not going to delete this function. We're just going to comment it out. Well, we don't have to comment it out here, actually. We'll just put a caution comment here, and we're gonna disable or comment out the places where the function is called. So first, we will set up a caution comment which says below function 528, and then we're gonna say determined that since we are using 1x per main while loop save system, we will not be using this function until we have finished and tested the 1x per system. And I'll just put therefore commented out all function calls associated with this function, or all function calls of this func, until if that ever happens. I'm just going to definitely do not delete this, as it was thoroughly created and fine-tuned, and would be the logical next step in data persistence for a more up-to-date save system. Alright, so let's go ahead and find this function call. So we'll do Control-Shift-F, and Okay, so you can see where we have these functions, and we're gonna put a commented out, and we'll put a caution comment above each one. And red is the color that we use for caution comments to just stand out. We're gonna say commenting these function calls out until we end up finishing and testing the 1x per main while loop save system. So commenting these function calls out until we end up finishing and testing the 1x per main while loop save system. Alright, so I'll copy this, and now we're just going to go through, and we're going to just comment all these out and add the comment. So I bought some new pillows. Fucking pillows suck. Definitely returning them. They're like good to like sit back on. They're not good sleeping pillows. They're like fluff, like cushions. They're like cushions. They're not fucking pillows. They're like, it's like I bought a cushion. It's not what I wanted. Big ass pillows for nothing. They're just like big and not soft. Who wants a big hard pillow? Weird. Okay, so there we go. We did disable all of those. Let's do let me make sure I'm not being an idiot, and I did it all. Yeah, so there was only 3 function calls. The rest is in SQLite test. So we did test this as well, which is cool. We actually tested it all. And you can see our devlog, how much we worked on it. Alright, so just salute to that function for now. Maybe one day we'll use it, but life goes on. Alright, so next one. Below function. Quite certain we don't need checkpoint ID anymore, since we'll be using only 1x checkpoint, 1x per main while loop. So this goes along with like so this goes along with the idea that we're going to have multiple checkpoints. Basically, like per while loop, we are going to have save sections that are just checkpoints where we would save the state of the game at. That, you know, included the previous function that we were just talking about. Like every time you added a card to a card group, that's a checkpoint, and the checkpoint ID would dictate the logic that we would use when we reloaded the game back in, you know, to determine like where to pick up at the correct location and load in only, like, you know, to load in the data properly in a proper order. You know, it's like surgery. You got to do it right. If you're operating on the eye versus the foot, it's obviously like a different procedure. So anyway, I think we can leave the checkpoint ID actually as a vestige, and maybe we'll leave it. I mean, maybe we'll end up using it if we implement this custom appendless save function again. But currently, we're not going to use it, but we're not going to delete it either. So what we'll do is we'll just modify this to instead be we'll just default it to none. So checkpoint ID would be default to none purpose, and we'll just add a comment here, just like we did with the previous function, and we're gonna say can modify this, since we will be using only 1x save checkpoint system to start 1x per main while loop. We aren't going to be using checkpoint ID because there's really only one checkpoint. There's only one checkpoint with that system. we are going to be using checkpoint ID because there's only one X checkpoint with that system. And I'll just put keeping it around just in case we end up using the more robust system with multiple checkpoints per main while loop. There we go. Alright, so we have the purpose function which creates a new stable save state in the database, transfers data from save data to save data stable and save data stable backup. Params takes checkpoint ID, type in purpose checkpoint, blah, 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 blah. Yeah, we know that. Yeah, easy. Alright, cool. So we'll leave that as it is. We're just not really going to use checkpoint. So what happens with this function and where is it called? Let's see, because that's really what we're supposed to be looking at. So where is it called? Okay, I see. There's... Okay, I understand. Okay, so where is this called, though? Where is the stable save state function actually called? Because what it does is it gets the current time, it serializes it, and then it inserts into save data. And couldn't we use the... couldn't we use the function to do this? Isn't that what it does? We serialize the data and then it inserts or replace into save data, object name, values. Isn't this the same thing? This function right here. Oh yeah, and we're gonna rename this one. So this one needs to be renamed. Let's go ahead and take care of that first. So we have places where it's called in client. Okay. So this code might not actually be used. Data save function p1 name. Yeah, so we're not actually gonna use this. See, because this is vestigial code from the first pass system, and we're not using that because this would be a more than one location save system. This would be a multiple checkpointed save system. We're not doing that. Okay, so then we have index num for tracking index number of below for loop, used for creating truncated list of apply list for proper visual data save function data arc passing. So this is another vestigial set of code that we created. It's vestigial temporarily at least. So we have iteration through the apply list, and we are saving the updated apply list. So this is just a more precise save system that we're not going to use at this point in time because we're starting off simple. We started off zoomed in and trying to be Superman with the save system, and it just wasn't the correct approach. We should have started out simple. So are we actually going to use the current client.checkpoint ID? Yeah, so this is just going to end up getting commented out. I didn't realize we had so much of this code. It's okay. It's fine. What we're gonna do is we're going to visual data save function, cargo name, cargo data list. I see. I see what we must do. So this needs to be commented out, first of all. So we added this. If adder name string is equal to name for save system, since this is the only place name is set, this is where data must be saved for data retrieval. Do we not have name in the list? Of course we do. Yeah, we do. We have P1 name and P2 name. Easy. Very simple. So here's what we're going to do. We're going to comment that shit out. So this whole section is going to get commented out. And this is just a more precise save system implementation that we initially thought we were going to go with, but it's too complicated because loading back in and all the associated logic at least seemed to me like it was going to be challenging and like it was kind of overwhelming, so we're going to go with simple first. So let's just comment this out, and because we don't actually want it to save, we just want only the the 1x per while loop. We don't want any saving going on other than that because that would mess it up. So this needs to be tested. We can leave that. We also will say that with the save system we have to update this date to be 5/28, and we're gonna say that we determined that we are disabling all code associated with more precise / frequent saves. We're disabling all code associated with more precise frequent saves, and until we have finished and tested the 1x per main while loop save system. We may or may not eventually end up using this code again, just not right now. Right? So there we go. Those are, and then we have the index num here. And this previously returned the checkpoint ID, the stable save state function. Does it still do that? Does the stable save state function still return checkpoint ID? Okay, it does. So we're gonna modify that. Well, we actually don't need it. We don't need it to do that. So we can just literally comment this out. So we'll comment it out, and then we're gonna have a comment, a caution comment. It's a little bit of a surgery we gotta do on these functions, but overall I think we're gonna keep pretty much mostly how it is. Disabling this, since we are not going to be using the checkpoint system until we have finished and tested the 1x per main while loop. Save system. So what else do we not need? Well, we don't need the checkpoint ID. So we can comment this out. And then this. And this actually could have been replaced, I believe. So we have serialized checkpoint ID, insert or replace checkpoint ID. Yeah, so it's those 3 lines. So we'll say below 3x lines. Okay. And then also, can't we use, let's just put that as a side note. Also, can't we just use the visual data save function? To streamline this process, since it internally serializes and inserts the data to the DB. And I'm pretty sure that is true. So what we'll do is we're gonna add that comment like here. Like this. Can't we just use the visual data save function to streamline the process since it internally serializes and inserts data to DB? Yeah, and I'm pretty sure we can. We're gonna take care of that. I'm kind of like spread thin here, making sure I do everything. There's like 5 different things I'm doing at the same time. Okay, so this is going to be disabled because we're not going to be using it right now. 3, 4, 5, 6. Temporarily disabling until we are finished test. Since we finished tested the 1x save system. Using check more precise save system. Temporarily disabling until we have finished and tested the 1x per manual loop system. We aren't using the more precise frequent checkpoint save system. Yeah.
In a long dream, it creates worlds that have no summers, and it shivers under black
Okay, shit's complicated.
and it takes its sad creation
It's really not though. It's just a lot. It's not complicated, it's just a lot.
to cure its of sorrow, destroy it. The sorrow is part of its own task. We cannot interfere. Sometimes when they are deep in dreams, I want to tell them.
We're checking index number, blah 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 blah. Commented out. This whispering in the background is distracting. Temporary disabling to finish test of 1x per main while loop system. So database. Then we disabled the current client checkpoint ID. So that's good. I want to make sure we're not disabling anything that we need. So we have the all the rest of that stuff is still necessary. We also disabled this index num. Okay, cool. What's the next? Should probably add in visual support. Okay. There we go. And now we're going to rename it because the naming is bad. Yeah, we're going to rename it. So let's go here. And what are we going to rename this to? Well, what does it actually do? It actually just saves, it serializes the data, and then it inserts it into save data. It's very simple. It just saves us, you know, having to write this out every time. So we could just call it serialize and insert function. How about that? Serialize and insert function. So we'll say what we need to do is do a copy this, Control C, go here, Control F, paste, and then we're going to change this to be serialize and insert function. Alright, so let's go ahead and replace. So now it's visual data save function is serialize and insert function. Alright, going to the next. Next one. Bam. And we'll want to change it in SQLite test as well. In devlog, we don't need to worry about that. In things to do though, we can modify this. Actually, we're going to undo this. We're not going to worry about modifying the things to do file. See that how you have to clear the replace field? That's dangerous. You gotta be careful with that. Okay, so the only place this exists now is in devlog and things to do, so we're not worried about that. Alright. It's creeping progress, but it's progress nonetheless. We're gonna check to see real quick, where is save db setup function? See where that's called. So that's called already in client, and then it's defined here, so that's the only place it's used, and then we tested it. Okay, so that one's good. Serialize and insert function, we just took care of that one. Next we have custom append list save function, which we already, I'm pretty sure we went through that. I'm going to triple check. Yeah, we did disable it. We don't need to rename it or anything. That's where it's defined. Okay, cool. So we're safe on that one. Next is going to be the stable save state function. That's where we were working, I think. So the stable save state function. Alright, so what does this one do, and in the context in which this is called, how does that relate to the overall structure and how we're going to end up calling the save state function, which is really the broader task that we were supposed to be taking care of. Okay. So, it gets the current time. It serializes this current time. We say, can we just use the serialize and insert function, streamline this process, since it internally serializes and inserts the data to DB? Let's go ahead and take care of that. I'm pretty sure we can, because look, all it does is it pickle dumps the data, which is what we do here. Pickle dumps current time, and then self cursor execute, which is the same exact cursor. It does insert or why do we do insert? Why do we do insert on conflict do update versus insert or replace into? What's up with that? I remember we had trouble getting one of the syntax to work. Remember? I remember having problems with this. I need to check it. I gotta check it. Let's see. Let's check on conflict and see if we actually were able to get that to work. So we have SQLite test upsert ultimately inserts new row since it doesn't exist yet. Ultimately updates existing row. Didn't we have a more complex? Doesn't work for some reason. Can't figure out. Use insert or replace into method below instead. Yeah, see, this is what we were saying. We couldn't get the insert into select all from save data on conflict, do update set value. Working method, insert or replace. Select, so that's for selecting all. But what about specifically this, where we have the object name, the serialized data, and then the serialized data? Let's see. So it's object name, value, and then object name. No, wrong. It's object name, value, and then value. So we have object name, serialized data, serialized data. So insert into save data, object name, value. What about this one? It says insert into save data, object name, values. Values, yeah, they both say values. But here we do P1 score 3000. Oh, because we don't have the value equals. Okay. So in this case, we want to do set value equal to. So we would just basically have. We have double. Okay, so we do have double. Alright, so let's copy this. We're going to copy this line like so. Now we're gonna go over here, and we're gonna paste this in, but it's gonna just say cursor instead. So I have cursor, execute, insert into save data, object name, value. On conflict, object name, do update, set value equal to, and then we have object name, serialized data, and then serialized data. So we're gonna say object name here equals just name. Then we're gonna have serialized data equals pickle dot dumps, and we'll just serialize 3000, and then that's all we need. But at the top we need to import pickle. It's already done. We need to set up the cursor, and option isolation level test enables auto commits implicitly after each statement. We do want that. Okay, isolation level is none. If you should set it to none, it defaults to deferred. Wait, why is this? Okay, I see. Oh, that's just like a comment. I'm an idiot. So we have option 1, GameCon equals auto commit enabled. So we're gonna do GameCon, and then we have, where's the cursor? Game cursor equals GameCon cursor. Option 3. Cursor execute. Well, we use game cursor. So why don't we just call it cursor? Cursor goes GameCon cursor. What else do we need? Game cursor execute. Create table not exist. Create table. Insert into table. So we have to create the table. I don't know why I felt like I had to do that. I'm dumb. All we need to do is this. Isolation level equals none. So we do want auto commit. So we added that. Actually, let's just do it like this. Now we have two. Now we need to retrieve the data. So what we need to do is we have to say cursor.execute select from save data. Select all from save data where object name is equal to placeholder, comma, parentheses. I hate this fucking syntax. It's a nightmare. And it is equal to just name. And it has to have a, not Bane, name. Has to have a comma. It's a nightmare syntax, honestly. Probably the worst syntax I've ever dealt with. Hands down, SQLite. Terrible. Hate it. 0 out of 10. Select all from save data where object name, blah, blah, blah. Okay, now we need to do fetch all. So we'll say cursor dot or fetch one at index 0, right? Isn't that how you do that? Yes. Deserialized data equals pickle load. So we just copy this and then we'll add it right here. And we'll just say deserialized data equals cursor fetch one at 0, but we're gonna do pickle dot loads. So I actually did the wrong thing. I know I did the right thing. Pickle loads cursor fetch 1 0 converts from byte object to Python list, and then we just need to print the deserialized data. Okay, so now if we run this, I'm pretty sure we're gonna get an error, but let's cd out to or cd into Canasta. CD Canasta testing, and then we do SQLite test. Okay, no such table save data, because we didn't create the save data table. Okay, we didn't. Yeah, that's true. So we have to create the table. There's to create the table. Cursor create table. Blah 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 blah. All right, now let's try it again. Okay, now we're at 109. Deserialized data. Pickle like object required, not string. Oh, right. I'm an idiot. So we have object name, serialized data. Alright, I see what we're doing here. We're just going to change this to say serialized data, and then change this to serialized data. Right? Now if we run it, let's see what happens. Okay, 108. A byte-like object required, not string. Okay. We have the object name, which is equal to the string name. We have the serialized data, which is pickle dumps, and we're just dumping 3000. So we're serializing 3000 into a serialized version. Then we're doing cursor execute insert into the save data table, passing into the object name and value fields the value, or the object name for object name, and then the serialized data for the associated value. And then on do update value, we also would do serialized data. So we're just it's the same data point. It's used for both values in the case of if it's an initial add or if it's an update. So that should work. And then we have a cursor execute select all from save data, where object name is equal to name. So the object name should be equal to name in this case. So then when we fetch it, we do pickle loads, and we're loading the cursor fetch one at index 0, and it's telling us that there's an error with this line. It says a byte-like object is required, not a string. Oh, it's selecting all, so it's going to be selecting object name and value. So object name is not serialized. Right, so we need to do at index 1, right? Or to be more precise, we would say select value from save data where object name is equal to name. I think that was the... There we go. Now it works. Okay. Yeah, SQLite's still a little fuzzy with SQLite. So that works. But what about when we update it? Now let's do it, run it again. And it works again. So it works every time. So this syntax works. I don't know why the select all related syntax didn't work, but I just wanted to verify that this indeed does work. So this syntax right here that's in serialize and upsert compared to this syntax here, which is insert or replace into. I know that do update set is supposed to be superior for whatever reason. Insert or replace versus do update set. So let's see. Insert or replace versus do update set, which is faster, better? The better option depends on your SQLite dialect, use case, performance goals. Insert or replace is faster than on conflict do update because it avoids checking field by field changes. It actually deletes and reinserts the row. It triggers delete and insert, not update. Insert on conflict column, do update set. Updates existing row if conflict on specified columns. Say if you want to preserve row ID, timestamps, or relationship. Can update only certain fields conditionally. Use insert replace for speed and simplicity if you don't care about preserving row metadata or foreign keys. Use on conflict do update if you need granular control. I thought we determined that insert or replace was faster. I mean, insert on conflict. PostgreSQL. This is standard, only option on PostgreSQL does not replace. Both DBs, example SQLite dangerous foreign key. Better preserves row, insert into values on conflict do update set. If using PostgreSQL, go there. If using SQLite, only if you fully understand the implications. But are you sure it's faster? Is insert or replace faster than conflict? Yes, it can be, but only in certain cases. Insert or replace deletes the existing row if a conflict is found. And inserts, this is often implemented as delete from table where conflict target is equal to value, insert into table values. So insert or replace faster because it avoids checking which fields change or performing conditional logic. No need to scan the existing row to compare values, minimal logic inside the engine, less overhead. On conflict, do update potentially performs an update rather than delete insert cycle. Potentially slower because it reads the existing row applied to your custom logic. May require computing diffs, evaluating expressions, and updating only specific fields. Maintains row ID and foreign keys correctly. Row benchmarking example tested with a table with 1 million rows. Insert or replace is 25% faster on average in bulk inserts. But with foreign keys enabled, performance drops significantly due to cascading deletes. Due to foreign keys enabled. What exactly is a foreign key again? A foreign key is like connecting two rows to each other through the foreign key, right? On conflict, do update was more predictable and stable when triggers or relationships exist. Yeah, so relationships refers to foreign keys. Gotchas with insert or replace. It can break foreign key constraints by deleting referenced rows. Triggers delete and insert fire instead of update triggers. It resets auto increment behavior if using row ID primary key. So insert or replace is often faster. So on conflict, do update is slower. So insert or replace is actually simpler syntax because it's just insert or replace, and then you write one thing: save data, object name, values, boom, boom. So you don't have to have that third slot for the values for do update set. Plus, it's a little easier to read. It's just like less gobbledygook to look at. And then foreign key, I just wanted to be reminded. I'm quite certain of what that is, though. Foreign key is a way to link data between two tables in a relational database, ensures the relationship between two tables is valid, maintaining referential integrity. A foreign key, blah, 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 blah. Yeah, we already know about this. Okay, so we're not using foreign keys here. So we're not worried about foreign keys. So let me just go to the top here, and I'm going to put... well, first of all, let's get rid of all this shit that we just did. Gonna do all that. We will keep that though. Okay, now we go up to the top, and then notes on conflict can use SQLite direct. Blah, 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 blah. Upsert speed method benchmark. Add a DB when you don't know if row exists. Upsert method speed, adding DB when you don't know if row exists. It says insert or on conflict do update was the fastest. It said insert or replace was faster compared to select, update, insert. And then insert on conflict do update. What about it? But before you told me that on conflict update was faster via this benchmark. Yeah, this is what it did. It said this. I don't know if I tested it. Did I? I don't remember. You're doing so. Thanks for pointing out. Let's resolve this apparent contract legally incorrectly. Summary of the conflict info. Sometimes faster, reliable, but slower. Slower, maybe. So what gives? Clarification. Benchmarks depend on context. No shit. The key differences are the database system used. Most benchmarks showing inserted are faster on PostgreSQL. In SQLite, inserted bits can be faster in some limited cases. If the benchmark includes foreign keys, triggers, or row ID use, then or replace incurs more overhead because it deletes inserted. To update just updates and avoids all that. How many writes actually cause conflicts? If most rows conflict on conflict do update is automatically skip unnecessary field changes. If most rows do not conflict, insert without. Why on conflict do update is usually fastest. Most reward updates are unique and foreign keys triggers which is both speed and correctness. Okay, the benchmark you referred to like this. You're absolutely correct in practice. Okay, so with SQLite 3 and no foreign keys, just 2 fields in the DB table using Python. With most of the time conflicts being the case, which would be fastest? On conflict, do update, or insert, or replace. No, very specific answer with confidence. You can see with like 3 foreign keys, tip is only 2 columns, key value. Most inserts will conflict already exist using Python. Insert on conflict to do update is generally faster than insert or replace. Why? Internally performs delete insert. This means deletes existing row, inserts new and triggers and side effects. Deletes inserts are more expensive than updating in place. Insert on conflict do update only updates the conflicting row. No row ID changes. Less disk I/O and less internal processing. SQLite optimizes paths. Blah 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 blah. Here's a quick benchmark you can run to verify. So we have this benchmark expected results. It's showing that the insert or replace is very fast, but on conflict do update is a little bit faster. So on conflict do update is the faster, which is what it agrees with that previous benchmark. So we were at 1.8 and 3.5. This one is 1.2 and 1.7. Okay, so I guess we'll just test it ourselves to see for sure. Insert replace key value, data. Commit or replace. Commit. Why does it use time.time? Why don't you use time it? Can you redo the test using time it? Absolutely, by that time, I want to get more accurate. There we go. Output, insert or replace. Typical results of modern hardware. 1.96. On conflict update is 1.4. With generally holds on conflict is consistently faster in this scenario. Time it is better resilient because it's not running. So 1.4 versus 1.9. So on conflict do update is supposed to be faster. I'll go ahead and I'll run it and see, just to verify, make sure it's not tripping. Sometimes AI hallucinates, but it's pretty smart, honestly. So let's create a new file real quick. We're gonna create a Python file. We're gonna paste this in here. We're gonna save it as SQLite test AI.py, and now we're gonna do py SQLite test AI py, run it, and there you go. So you get on conflict is 0.11, on insert or replace is 0.14. So the let's see, how often though is it all conflicts? Time replace, time update, insert or replace. Have current conquers okay, do insert into key values k at I, a k at I init for I in range of 100. Is that a way to write 100,000? Data is k at I, v at I, for I in range of 100,000. Insert into kv. I'm so confused by this fucking syntax. I'm gonna go take a little break real quick. I'll be back. Actually, you know, I think I'm gonna go to the gym. I'm gonna take a break. I'm gonna go to the gym. When we come back, we will verify this. So I'll just put a little comment here, because I do want to make sure that we're using the right one. I don't want to be sloppy. Need to determine, and this needs to be on the next line, I forgot. Need to determine that on conflict do update is indeed faster than insert or replace given our specific requirements. This was generated by AI ChatGPT. Need to ensure the test method does mostly replaces overwrites, since that is what our real world process would include. Okay, so this is line 2 in SQLite test AI. So let's go right here, copy this. Just stopped at line number 2 in SQLite test AI.py. We're going to say continued determining proper order of operations, or, well, actually, we're just going to say went through, or began going through save logic.py with a broad perspective to modify existing code and associated function calls to disable / remove certain vestigial code blocks, added caution comments, modified logic namespaces to make more sense. / align with new system changes. Begin testing which is faster. On conflict do update or on conflict do update versus insert or replace. Okay, and we went to 12:45. So that's an hour and 20 minutes. So we'll just say 1.5 minutes or 1.5 hours. So this was, we stopped at 12:43. And now we're going to stage and commit our changes. So it's 12:44 to 12:45. Alright, so we copy all this. Let's just triple check it. That's the date. 12:44 to 12:43. Stopped at line 2, and then we stage committed push changes, so that's correct. We copied it. Now we're going to cd out to the root of the project directory because we have to be there for it to properly stage everything. Now we are in the proper location. We can do git branch to make sure we're on the right feature branch, which we are. We'll do git add to stage the changes, git commit -m double quote, paste in our devlog. There we go. We have 8 files changed, 91 insertions. Now we can do git push. So it's going to push up to the cloud. There it goes. Alright, now we're going to go ahead and close this. Get all that out of there. Go over to programming projects, Canasta. Copy this one. Go back out. Change this. Accidentally deleted it. That was a big oops. So now this is going to be renamed to be the 28th. And now we'll go inside, delete the old one, and then we'll paste the new one in. Go to text, devlog, all the way to the end. So we got 528. There we go. That is indeed correct. So we're going to back out here, and then, yeah, all right. So we're done for now. We're going to go ahead and go to, I'm going to eat a little bit, then I'm going to go to the gym, and you know how it is. And I'll come back, and I'm going to do a second session today. We're doing 2 hours today, at least, okay? We're getting back to the 2 hours, all right? It's happening. So I'll see you. Good progress, good session. A little bit sidetracked, a little bit of bullshit, testing. You can say it's pointless, but I'm gonna be saving rather frequently. So like those little milliseconds, they do add up. They do cause performance hit. You might think, oh, you know, what's a quarter of a second? Well, when you're doing when it's a quarter of a second performance hit, and it's happening, you know, over and over, like, you know, stuff like that adds up. It just does. So anyway, we'll make sure we pick the faster of the two, finish that little bullshit we were doing, modifying and making those minor improvements to those couple other functions inside of save logic, and then we'll eventually have gone through the entire file to get it nice and like up to date. Since our finishing of like, you know, the newer finish, like final pass of the system of how it's going to actually be, then we're going to figure out how the save logic function or save state function, sorry, gets called in the context of those other functions and in the context of the client file whenever it's, you know, they're playing the game, to make sure that it's, you know, properly structured and all that. So yeah, we're going to do that when we come back, and should be able to finish like all that today. In our next hour, we should be able to like to start working on the save state function, implementing that special code for each object in the master save object list, which is really what I wanted to do. So we can finish that list we can finish going through that list for the save logic, and then all we have to do is go through and finish it for the load state. I keep saying save logic, save state, and load state functions. That's the two we really got to finish, and